We are starting a new module called linear equations. Once we finish this module, we should be able to extend, connect, and apply unit rates and proportional relationships to linear equations and graphs. So for our very first lesson, we're going to be looking at writing equations using symbols. Our LEQ question would be, how can I write mathematical statements using symbols to represent numbers? So before we get started, let's go ahead and look at some vocabulary. That's just going to be a refresher to help us through with this lesson. Okay, so the very first vocabulary I have is even. And remember, even numbers are numbers that end with, that start off like 2, 4, 6, and they continue. Or this could be 52, 54, 56. Okay, and then our odd numbers are the opposite. They're 1, 3, 5, and 7, and they continue to go on. Another review would be consecutive. So consecutive just means in order. Okay, so up here I have um, consecutive even numbers because I went in order. I did 2, 4, 6 instead of saying even numbers 2 or 52 or 82. That would be considered consecutive. It has to go in order. And then just for my very first module, when we're going over exponents, as a refresher, we have squared. And when we see squared, that means the number's being raised to the second power. And then we have cubed, which a number would be raised to the third power. Okay, so you might want to jot those down, especially the ones that seem new to you or you don't remember, because we'll be using it throughout this lesson. Okay, so let's go ahead and talk. Let's look at this statement here and then this equation here. So starting off with the statement, have the number 1157 is the sum of the squares of two consecutive odd integers divided by the difference between the two consecutive odd integers. Well, this statement here is the same thing as this equation. So this statement would be similar to if you had a word problem that was given to you, or what we like to refer to is an application. So looking at that, we only have, a lot of times with word problems, we'll have our numbers and we know exactly what numbers we're using to solve it. Well, this time we have x in here. So x is going to be our unknown number that we are trying to find. Okay, so basically for this lesson, all we're going to do is translate. We're going to have some statements and we're going to translate them into symbols. Now, this was introduced by René Descartes. He's a French philosopher, and he introduced using letters to represent numbers and mathematical statements. And by doing that, it saved time and also labor. Okay, so for my example 1, I have a whole number has the property that when half the number is added to 15, we get the number itself. So here I have half of that number added to 15, and then our result is the number itself. Okay, so this example is exactly what we're going to be doing in this lesson here, just translating statements into equations, mathematical symbols. Okay, so before we even get started, I would like for you to write down these steps. I'm going to be referring to these steps. This kind of helps guide us as we are annotating the mathematical statements. So the very first thing we're going to do is define the variable, and that means to let x be the whatever we wanted to represent and it would be based on a statement. So the last two statements we had, X was represented in a number. X can represent an item like cookies, or so it's whatever the unknown that we are looking for in the statement. For two, express the variable. So how do we write it? So now we know we're going to use X. How are we going to write it as an expression? And then we're going to put those two expressions together using the equal sign. All right, so let's go ahead and look at our next example. It says, when a number is taken away from 57, what remains is 4 more than 5 times the number. So we need to define the variable. So I'm going to let X represent a number because we don't know what number they're talking about. So that is our unknown. And now our second step is to express the variable. So we're going to use this variable to write two expressions. So when a number is taken away from 57, so I have my number and I'm taking it away from 57. Okay, so that's my first expression. And then my next one is, what remains is 4 more than 5 times the number. Okay, so I know I'm going to have 4 more, which means I would need to add, and then that's going to be 5 times the number. So for 5 times the number would be 5x. Okay, so remember now that we're using x for any multiplication problems, we're going to either have it like side by side, the coefficient and the variable, or we're going to use parentheses. Okay, the very last part is to put the two parts together using the equal sign. So I have 57 minus x equals 5x plus 4. So this is just one way you can actually solve it. There's some other ways, especially for my ELA students. If you're very strong with ELA, you might just want to annotate this. You might not even need to use the steps. So when I'm talking about with the annotating that you guys are doing right in your ELA classes, is going right along here. It says when a number, okay, so I don't know what number it is, so I'm just going to put an X right here, okay? So that's my unknown. And it says it's taken away. So to take something away, we know we're going to minus, and then we have our 57. And then it says what remains is 4 more. So I'm going to add 4 more than 5 times the number. And I just have the 5 times, and then there's my number. Okay, and then what we do is just put it all together so we can have our equation. All right, let's look at another one. Okay, so for this example, we have 3 consecutive integers is 372. So I'm going to let x be my integer, my very first integer, because that's my unknown. I don't know what it is. So we label that as x. Is going to represent for equals. So all of this, these 3 consecutive integers are going to equal 376. So the way that it's written, here's my first integer plus my second integer, and then plus my third integer. And that is going to equal 376. All right, let's look at example 5. This time I have 3 consecutive odd integers. Okay, so x this time is going to be my first odd integer. Okay, so this is going to be my first odd integer. And we have is again, so we're going to have it equal 93. Okay, so I need 3 consecutive ones. Now this one's going to be a little bit different. We are going to start off with our very first odd integer, which is x. But this time we're going to add x plus 2. Okay, so that's my second consecutive odd integer. And then my third one is x plus 4 equaling 93. Okay, so the reason why this is plus 2 this time is because remember, if I have my odd number here, I need my next one to be also odd. So I'm adding 2. So if this was 1, if x equaled 1, I have 1 as my first number, and then 1 plus 2 would be 3. So that would give me my consecutive number in order. And then this one would be 1 plus the 4, which would give us the 5. Okay, so here on the screen here, I have the steps that you can use as a guide to guide you through with these questions. We're going to work with these questions in class, and I'm going to have you guys in groups, okay? But I want to give you a chance to go ahead and look at them and see if there's any of them that you can go ahead and answer now. Go ahead and write your symbols in for. Okay, so for our closing, just remember, begin all word problems by defining your variables. State clearly what you want each symbol to represent. Written mathematical statements can be represented as more than one correct symbolic statement. And break complicated problems into smaller parts or try working them with simpler numbers. Okay, so when we do the steps, this is one thing that we're doing is breaking it down in a little bit smaller parts to help us understand. All right, this is the end of the video here, and I will see you in class.